NASA's Juno spacecraft has officially crossed the barrier over into Jupiter's magnetosphere, the powerful magnetic field that extends millions of miles around the planet. Within this magnetosphere, particles move based on what's going on inside Jupiter. NASA believes Juno entered this region of space between June 24 and 25. Now, the vehicle is continuing even further into the field and is slated to arrive at Jupiter on July 4, when it will insert itself into the planet's orbit. It will allow the spacecraft to study the gas giant in more detail than ever before. Jupiter's magnetic field, which is about 20,000 times stronger than Earth's magnetic field, is considered to be the largest structure in our solar system. If Jupiter's magnetosphere glowed in visible light, it would be twice the size of the full moon as seen from Earth, said William Kurth, lead CO investigator for Juno's Waves investigation. The magnetosphere is constantly being bombarded by charged particles streaming from the Sun, called solar wind. Some of these charged particles get trapped inside the magnetosphere, as well as particles coming from Jupiter's volcanically active moon Io. The result, parts of the magnetosphere are a radioactive hellscape that can potentially fry any electronics that venture deep inside. But on the bright side, the field is also great for making some stunning aurorae. Right now, Juno is just at the edge of the magnetosphere right now, so things aren't quite hellish just yet. Prior to crossing over, the spacecraft was traveling through the solar wind, where there were about 16 particles per cubic inch. After crossing into the magnetosphere, that particle density dropped about 100-fold, according to NASA. That's because most of the particles within the magnetic field are concentrated closer to Jupiter. During the crossover, Juno's onboard instruments were able to measure this huge change in particle density as the vehicle transitioned from the solar wind to the magnetosphere. On June 24, the spacecraft first crossed through the bow shock just outside the magnetosphere. That's where the incoming solar wind clashes with the edge of Jupiter's magnetic field. The bow shock is analogous to a sonic boom, said Kurth. The solar wind blows past all the planets at a speed of about 1,000,000 miles per hour, and where it hits an obstacle, there's all this turbulence. NASA translated Juno's measurements during the crossover into an audio file.